Hello everyone, my name is Shreya Patil and here I am presenting my work on predicting the resolution of protein structures using X-ray diffraction data. In structural biology study, different protein properties are studied from their three-dimensional atomic structures, and this knowledge can be further used in protein engineering and drug discovery methodologies. To obtain this three-dimensional structure, X-ray crystallography, NMR and cryo-EM, these are the different methods we can use. Amongst them, X-ray crystallography is the most widely used and most efficient method. There are several factors like crystal dimension, crystal properties and X-ray data collection details which can affect on the resolution of atomic structure of the protein. Throughout this project, we will try to understand the X-ray diffraction data and how it is affecting to the resolution of the protein structure. From the image we can see that the first image, which has 1 angstrom resolution, shows all the bonds in the protein very clearly as compared to the image which has 3 angstrom resolution. For this project, I have converted our target values into good or bad resolution categories, considering 2 angstrom as a threshold values. As a part of exploratory data analysis, I have dropped the features which has largely missing values, converted some of the features data type to the appropriate values, also converted the categorical features data to the uppercase. After doing all these steps, the final dimension of the dataset is approximately 108K observations and 15 features. For the numerical columns, we have observed there is a high multicollinearity issue among some of the features. We have used VIF score to identify those features and we have removed them. From the image we can see that our work are observed high resolution limit, data collection resolution. These features has high collinearity between other features, so we have dropped them. After doing all this cleanup on the data set, these are the final features which we will be using for our prediction. Amongst them, resolution is our target value and all other are our feature columns. As our target value is binary class, I am using logistic regression with regularization. For the hyperparameter C, best performing model has chosen C value as a 10 with accuracy score 0.84. As we have seen earlier, our target value is pretty balanced, so we will use accuracy as our measure for the model. To reduce the complexity of our model, as we have 14 features to analyze, I have tried using PCA as a pre-processing step on the numerical data pipeline, but it hasn't given much of a hike in the accuracy score. Moreover, it has decreased the accuracy score than the previous value with n component value 10 to the 0.83. Second model which I have used for our dataset is decision tree classifier, which has given 0.84 accuracy for the initial hyperparameters. For the secondary hyperparameter search, decision tree classifier has chosen max depth 10 and minimum sample split to the 0.5% of overall data as the best performing model, which has given 0.85 as a accuracy and 0.86 precision and recall values, which are 2% higher than the logistic regression model. If we compare decision tree model to test and training dataset, we don't see much of a hike on training dataset, which is a good sign which shows that model is not overfitting to the particular dataset. For the further analysis, ROC curves are used to compare these both models. We can see that logistic regression model is slightly nearer to the diagonal, which says that decision tree is performing slightly better. If we compare the time taken by each models, logistic regression model took almost 8% more time than the decision tree model. Considering all these factors, we can say that decision tree classifier is the best performing model so far. Our model is giving 85% accuracy, which proves that there is a relationship between all the features we have considered and our target value, which is a resolution. To improve our model's performance, we can try using some ensemble methods as well as different features from the X-ray diffraction data. In this particular model, I have classified our target value into binary classes. Instead of doing that, we can try to predict values as it is using multi-class classifier, which might improve the performance of the prediction. Thank you.